Welcome, geometry class, to 11.6, nearing the end of the year. I hope you all are doing well. We're going to be talking about proportional parts of circles today. So when we got a circle, there are two lines that end up forming proportions. They're both based on the chord, but in two different ways. The other line that we're going to have that's going to end up being proportional is the secant. And when this occurs is when you have secants or chords that intersect. They will intersect outside of the circle, or they can intersect inside of the circle. Chords intersect inside, secants intersect outside of the circle. All right? So as we move forward, the first thing we're going to talk about is secants. And these two secants, they intersect at point C, which is outside of the circle. So we have AB times BC equals EC times DC. Now, another way this could be written, if you think about it, it's AC times BC equals EC times DC. So if we're looking at this, let's just kind of highlight things to help us see it better. We've got AB. AC. That's what I wanted to start with. AC times BC, so like the whole thing times the outside part, is equal to, and let's do this in orange. The whole thing in the bottom EC times, let's do this last one in purple, DC. So there's the proportion that we have. That's DC. Oh, that purple doesn't highlight over purple very well. Let's write that in there, DC. And BC should be highlighted so we can actually really see what we're talking about. And I'm taking my time here because I'd like you to see exactly what we're looking at. The yellow times the blue equals the orange times the purple. And if you're struggling with this, come back to a slide like this and just say, I want to color code it, because that can really help you if you're struggling. Sometimes, like I've said many times, sometimes if you take the time it takes in the beginning, in the end it takes less time. You might say that doesn't look like a proportion, and I'm telling you it actually is a proportion, and we can use cross multiplication to show that. So if we divided BC and DC, we could get AC over DC equals EC over BC. Now let me make it a little clearer as to what I did here. I took the second part of each and I divided them across. Now you can see how it kind of sets up this proportion. It doesn't matter if you use it through the multiplication side or the traditional proportion that we see here. All right. So now let's see what happens with chords. With a chord, you have the same thing occurring. So we have XP, which is part right there, is proportional with, let me see what's going on here, PM, which is the other half, as ZP is to PY. And I've always thought that this one was a little bit easier to understand than the secants, just because it's the one half of it minus the other half of it. You don't have to do the whole times the outside equals the whole times the outside. That can get a little bit confusing. So as we move forward, let's take these proportions and put them into practice. Okay. So here's my first one. It's where we have chords that meet inside. So according to what I saw on the last slide, that XP times PM is equal to ZP times py. And that's going to be really kind of easy on this one because I use the same letters. In the book, they might not use the same letters, and you might have to really sketch it out. But xp is 8, and pm is 6. zp is x, and py is 4. So 8 times 6 is 48 equals 4x. Divide both sides by 4, and x will equal 12. That's pretty simple, wasn't it? Let's keep moving forward, okay? Our next slide, I believe, is going to be the same exact thing, except for this time it doesn't have it completely in the diagram, so we need to do a little bit of legwork. It says from x to p is 3. But then, if you look here, it says, and we got to be really careful, we just can't rush through this. I see way too many times students rushing. It says xm is 9. xm, so if you see here, x to m is 9. If that's the case, that's not going to work in the proportional part that we've already stated, especially on the last slide. But what is from p to m? If the whole thing is 9, wouldn't that be 6? So when we're setting up xp to pm equals zp to py, now I know that xp is 3 and pm is 6. I had to do a little bit of legwork to find that 6 because it didn't just spell it out right at the beginning. Now, the other thing it says is that we need to find zy, and we know that zp is 2, so that part. And we actually have to find this. What we're looking for is zy, so we got to find the whole thing. Now, what we're going to find is we're going to find py, which is just part of that when we work this out. So zp is 2. We already discussed that and why that is. So what we're going to find is py. I'm not going to call that x. I'm going to call it py just so I'm very clear on what it is. So 3 times 6 is 18. 18 equals 2 times py. So py is going to equal 9. So if that's 9 and 9, not 2, 9, what's the whole thing going to be from z to y? I hope you said that it's 11. All right, let's move forward. All right, now we're going to be talking about secants that meet outside of the circle. As we've already said, and I got the formula right here, it's AC times BC equals EC times DY. So if I were to look up the first thing here, it says AC. What is AC? A to C is that. What is the length of that? I hope you said it's 5, because that's the answer. And B to C is 2. E to C, we don't know, because let me show you right here. E to C, and I'm going to get out a different color. E to C, this whole thing right here. Could you give me a measurement of that? I think you could give me D to C right off the bat. Isn't D to C 3? What about E to C? Is it X? No, not even close. I think it's going to be X plus 3. Because isn't that how we got AC on the top? The yellow line was we did 3 plus 2 equals 5. It's a little bit easier than to see that E to C, the green line, is X plus 3. But that's what it is. All right, so let's continue working this out. 5 times 2 is 10 equals, and just so you can see it, I'm going to switch these two. I'm going to use like the commutative property to switch those two values. 3 times x plus 3. Now, there's a couple of different ways that we could do this part. I could divide both sides by 3, eliminating the coefficient, or I could use the distributive property. I could take that 3 and I could distribute it to the x, and I could distribute it to the 3. I think that's going to be the easiest way to go, because we're going to say 10 equals 3x plus 9. So I multiplied the 3 to the x and the 3 to the 3 to get 3x plus 9. Now we're going to subtract the 9 and we'll get 1 equals 3x. Then we'll divide by 1 and we'll get x equals 1/3. That's what we were looking for. It doesn't say that I have to find anything else, but that's what x would be, is 1/3. All right, hope you understood how that worked. Let's work on another one here. And again, what I start out with doing is I want to see what I'm looking at. The first thing I'm looking for is A to C. So I'm even going to color and highlight here A to C to help me know that that's what I want, is A to C. Just like on the last slide, I just got to add those two values together. So I get 7. And then I want B to C. B to C is a little bit more straightforward, and it just says it right there. It's 4. And it equals, now this is where it might get even a little bit trickier. It equals E to C. Let's pull out a highlighter here again. And this is very, very similar to the last one, but it's got a different outcome. So we need E to C. And what would E to C be? From the last slide, you should probably be able to figure that out. And E to C is 12 plus x. You with me so far? Where this gets a little bit tricky is D to C, because D to C is also x. Oh boy. Okay, so that means what we're going to do is we are going to take and we are going to multiply the 7 and 4 to get 28 equals, and now I'm going to use again the commutative property just like last time. 12 plus x. This time I'm going to distribute it. Let's see what happens when we distribute that value. We're going to get 28 equals 12x plus x squared. Oh boy. Now what we got to, because they have an x squared and an x, this is something we've worked on a few times this year, where we have a trinomial. This is something from Algebra 1 class. So we get x squared plus 12x minus 28, 12x. That'd be easy if that was just a 12 without the x there. And so now we have trinomials, and remember we have to factor these. Actually, there's a number of ways we could solve this. We could use synthetic division or factoring or quadratic equation or completing the square. The easiest, if I can pull it off, is going to be to factor it. Because the last value is negative, one of them is going to be positive, one is going to be negative. My front values are going to be x and x. And I need two factors of 28. That's product is 28. And because one of them is positive and one of them is negative, the difference between the two is 12. Okay? Again, so their product has to be 28 and their difference has to be 12. So if I thought of the factors, that's why we call it factoring, of 28. So we're going to write down here factors of 28. 1 times 28 is 28. What other factors can you think of? 2 times 14 is 28. And 4 times 7 is 28. I believe those are all the factors of 28. Now remember, we're looking for a difference of positive 12. Okay, so we're going to give one of these a positive value, one of them a negative value. So like think about 28 and 1. What's the difference of those two? 27. That's not 12. So we're looking for 12. What about 14 and 2? What is the difference of those two? Well, that is 12. But how do I get to a positive 12? The answer is I'm going to have positive 14 and negative 2. And I'll show you why. I'm just going to explain this to you, how this works. If we FOILed them, first, outer, inner, last, we get x squared minus 2x, that's the outer part, plus 14x, that's the inner part. And the last part is negative 28. So it's x squared plus 12x minus 28. Let me rewrite that last one. I said it right, but I wrote it kind of wrong. Okay? Again, that's plus 12x minus 28. And I know I'm not an algebra teacher, haven't started teaching algebra at all, but that's a free algebra lesson because they assume that coming into geometry class that you have a good handle on algebra. Okay? So, but if these are the two possible answers, remember, these are called factors, and we're looking for the one that equals 0. So x, those are the factors, the zeros, because remember they equal, it says it right over here, equals 0 would be when x equals negative 14 or x equals positive 2. So the answer could either be positive 2 or negative 14. It's going to be positive 2 because it can't be negative 14. You can't have a negative distance. All right. So here we go, 11.6. This is the lesson that I have for you. I'm cutting it down because we're not here in class, and hopefully you're handling this homework being less. I know you're probably enjoying it. You're probably very happy that it's less. But let's do numbers 2 to 4. And let's do 6 to 14. So that cuts out don't do number 1, numbers 15 and 16, and numbers 19 and 20. Okay, we'll pass on those ones. That looks like enough homework for tonight. Have a good evening.